Okay, the final video for first order homogeneous difference equations is how to form a difference equation from a text. There are two types that you will experience. One will involve populations, either population growth or decline. The second one will involve financial maths, so that will be interest that you obtain on savings or interest that's added on via a loan that you take out. Okay, let's start with the population one. So I have a difference equation there. U of n is equal to k times u of n minus 1 plus c. That says that the value of the population, in this case, is a multiple of the previous term's population plus or minus a common value. So the k value, first of all, if the k value is greater than 1, then population growth is going to be occurring. In other words, the births are exceeding the number of deaths in the particular period. If k is less than 1, that's going to describe a decline in population. And then the c value is a constant amount added or taken away periodically. So if the n thing is describing the change in population every year, the c value is describing a constant amount being added or taken away every year. The population growth and birth then will always be in and around the 1 value typically, but if it's over or beneath, it'll be growth or decline. Let's have a look at some values, or some questions even. So question 9 in 12c, a farmer keeps his rabbits roaming freely on an offshore island. He estimates that there are currently 2,000 rabbits on the island. Now that's an initial value. So that's going to be my u of 0 or my u of 1. It doesn't actually relate so much to the difference equation as yet, in so much that it refers to the starting value of the population. So let's look at the next part. The population grows naturally by 10% every month. The farmer takes 100 rabbits from the island each month and sells them. So it looks like we're looking at periods of every month. So n equals 1 could be after the first month, n equals 2 could be after the second month, n equals 3 could be after the third month. And if we think about it that way, if u of 1 is after the first month, then the value at the start, the 2,000 rabbits, would be u of 0. So what we're looking to do in the first part is show the monthly population of the rabbits can be modelled by the difference equation. So here's how I think about it. The population grows by 10% each month. 10% needs to be converted to decimal form, so that's 0.1. So what that means is the population of this month is going to be 110% of the last month, but in decimal form, 1.1 times the population of last month. He also said that the farmer is taking 100 rabbits from the island each month. So that's a constant amount, so that's my c value. So I'm going to subtract off 100 as my c value from the difference equation. So the first star there is the simplest description of what's going on, and then adding in the extra information gives me the difference equation u of n plus 1 is equal to 1.1 of u of n minus 100. Now, we take stock of the thing that I have here and the thing that we're looking to show in part 1. We're looking to show that u of n is equal to 1.1 u of n minus 1 minus 100, whereas I have different subscripts. What I would do in this case is I would just change my subscripts to make them match the thing in part A there. The last thing then we're missing is the starting amount of rabbits is 2,000, so that means u of 0 is equal to 2,000. You'll notice as well I've got u of 1, so I filled 2,000 into the difference equation just above it, because we know that we need two values to obtain an A and a B in our general solution. Alright, so the difference equation there in the last line, for me it's that, but I would have adjusted the subscripts to match part A and make that work. Right, you can finish off the rest of the question yourself, because we're just looking at how to obtain the difference equation from the body of text. If we now go to question 10, it's another population question. It says in a certain country the current population is 10 million people, so that's the starting value again, not so much the difference equation part, just the starting value. Maybe u of 0 is equal to 10 million. We're told there's a birth rate of 1.8% per annum and a death rate of 1.5% per annum. Now we're going to have to put those together eventually, but the way I think about this just for this question is I'll do them separately and then put them together so you can see what happens if there's a birth rate versus what happens if there's a death rate in the country. Okay, the next sentence then is there's an annual inward immigration of 50,000 people per annum. So that's a constant amount coming in of 50,000. That's plus 50,000. And there's an outward emigration of 30,000 per annum. So that's a minus 30,000 per annum. Now, how do I form the difference equation? Well, we know there's a birth rate of that. So if I convert that to a decimal, that's 0.018. And if it was just the birth rate, what I would have there is u of, it should be n plus 1, there's a subscript, equals 1 plus 0.018 of u of n. And then if the death rate was 1.5, I'd have the difference equation u of n plus 1, again there's an error there, is equal to 1 minus the 0.015 u of n. But we end up putting those together, and when we subtract them, we get those combined will give me u of n plus 1 is equal to 1.003 u of n, or it looks like I've made the adjustment to the right hand side there rather than the left, and that form of the difference equation is fine there. U of n is equal to 1.003 u of n minus 1. And that's almost all of part A done. The only thing we need to now worry about is the emigration and the immigration. So if there's 30,000 going out, 20,000 coming in, that means there's a net of 20,000 coming in, and that gives me the difference equation there. Okay, that's the population difference equations. Now, if we're earning interest, so you know the form of the difference equation. If you're earning interest, the k value will be greater than 1. It'll be close to 1, but probably greater than it. And then the c value means, or the c value translates as if you're adding money to the bank or if you're taking money out of the bank. So let's say you've got savings in the bank. Your interest there will mean the k value will be greater than 1. And then if you have savings in the bank and you add €200 every month, you'll have a plus €200 in the difference equation. If you're taking out €200 a month, you'll have minus 200 in the difference equation. Something else happens then if it's a loan. So if it's a loan, generally the loan is earning interest, so k will be greater than 1. And then if the c value is greater than 0 there, it means that each month or each year, every time you look at the difference equation again, there's extra money being added that you owe. And that usually doesn't happen. What usually happens is the c value is less than 0, because what happens is the amount you owe decreases, basically because you will put in extra money every month or every year to decrease the amount of time that you spend paying off that loan. Okay, let's have a look at a few. Alright, 12D question 1. We have, on the birth of his first granddaughter, David opens a saving account and puts €200 in it. Every year, on the child's birthday, he lodges another €200, and then the bank gives interest at 2% per annum. And then we're looking to show that we can get this difference equation. This one's a tricky one because there are two separate dates here. There's the birthday of the granddaughter, and then there's a separate date where the bank gives interest rates, or the bank adds on the interest. And the bank will add on the interest at the start of the year, but it's likely that the granddaughter has her birthday at a different date in the year. It's not specified, so I'm going to make that assumption. So then how do you form the difference equation? Well, I'm going to look at it like this. Year 0, we start with a certain amount, there's nothing in there, and then later on in the year, he's going to add €200 to it. So by the end of the year, there's going to be the 0 plus the 200. That's the end of the year, there's going to be 0 plus 200 in the bank account. Then the bank will apply interest to that, so it'll be 200 multiplied by 1.02, because there's 2% being added on to the previous year's amount. Then the granddad adds another €200 to it, so at the end of the year there's 200 by 1.02 plus another 200 to it. That's the amount then going into the start of year 2, so that 200 by 1.02 plus 200, and the bank applies interest to that, so that's multiplied by another 1.02. he adds another €200, and we get a certain amount there. So what we want to do is form a difference equation from this, factoring in that at the start there was nothing in the bank account. So we have that as the initial condition. So then how do we do it? Well, we know at the start of the entire thing, at the start of year one, there's 0 in the bank account. There's 200 added throughout the year, and then the amount at the start of year one, the interest has to be accrued on the total amount. So what this is the interest added on the amount at the start of the previous year plus the extra €200. Now that's going to be a certain value. So the amount at the end of the second year is the interest accrued. That's the amount at the start of the previous year, and the 200 is added somewhere in the middle of the year, so that also has to be added onto that because it's going to earn interest as well. And if we repeat the idea then, for year 3 we'd have all of that plus another 200 multiplied by another 1.02. And it looks something then like this. And you can go through this again if you want, but the previous year, that's the amount at the start of the previous year. €200 is then added to that, and then by the end of the year, there's a certain amount of this amount in the bank account, and then the bank accrues interest on it. So one last time, that's the amount at the start of the year, then there's €200 added throughout the year, and the combination of the two of those accrues interest.